What's up, math scholars? Mrs. Harp here. We're going to learn about parabolas today. So I would have a calculator out, definitely, for some calculations. Have you ever seen a parabola before? Do you know what shape it makes? Yeah, perfect. So everybody shake your arms out. These are going to be your parabola arms today. Ready? Right side up parabola. Upside down parabola. Really wide parabola, opening up towards the sky. Really skinny parabola opening up towards the sky. Really skinny parabola opening down. Really wide parabola opening down. So we'll explore all those shapes today. It'll be super fun. So these values actually will generate a parabola shape. Can I have a volunteer fill out the table for me for a ticket? Jalen? You can do it in your head. Just tell me. What is negative 3 times negative 3? You know it in your head. 9, okay. What is negative 2 times negative 2? Good. Negative 1 times negative 1? Good. 0 times 0? Yes. 1 times 1? 2 times 2? 3 times 3. Now, let's look for something super, super cool. Oh, wait. I wrote that down wrong. Sorry. All right, this is what is super cool about parabolas. Do you see how this 9 and this 9 match? This 4 and this 4 match? This 1 and this 1 match? But then you have the 0, 0. It's because this parabola has symmetry. 0, 0 is called the vertex. That's our first keyword of the day. But then when you get to 1, 1, negative 1, 1 is its kind of like its reflection image. Isn't that cool? And then 2, 4 will reflect over to negative 2, 4. So all these coordinates on the right have reflection images over on the left. Isn't that cool? This would be a right side up parabola. Okay. So the lesson is officially called 9.1 Graphing y equals ax squared plus bx plus c. Okay, so here's our shape. It is called a parabola. This particular parabola is opening up towards the sky. I'm going to let you know what value can tell you that it's opening up towards the sky. Can you all see the formula? Y equals x squared. I'll write it bigger. It's really small. Y equals x squared minus 2x minus 3. So it's the number out front of the x squared that can tell you whether it's opening up or down. This particular one has an invisible 1. But since 1's a positive number, that's why we're opening up towards the sky. If this one had been a negative number, we'd be opening towards the ground. Make sense? So it's the leading coefficient. It's called the A value. So the A value tells you whether it opens up. I don't want to write this. The A value tells you if the parabola opens up or down, and it tells you how skinny the parabola is, how wide and skinny the parabola is. So I'll talk about that in a minute. Just by looking at that number out front, you know if it opens up or down and whether it is wide or skinny. Now, if the A value is positive, it opens up. If the A value is negative, it opens down. So that's what I'm trying to tell you right here. A positive A value opens up. A negative A value opens down. If the absolute value of A is bigger than 1, it is wide. So like 10 or negative 8, those would be, oh, I'm sorry, skinny. Skinny. The larger the number, the skinnier it is. And then the smaller the number, so if the absolute value is between 0 and 1, like 1/3 or 1/4 or 1/5, then it would be really wide. It's all you ever wanted to know about the A value. I'll just go go ahead and point out a few other features. You don't necessarily need to write things down. This guy here and this guy here, do you remember what they would be called? We learned about them this year. It's where they're touching the x-axis, that's a hint. They're called X-Intercepts. So the pink dots up here are X-Intercepts. I'll do a really similar dot with a green dot here. What do you think that green dot would be called? It's where it's touching the y-axis. Good, Y-intercepts. So the green dot is a y-intercept. There's only one of them. And then, what color haven't I used? Blue. This blue dot, do you remember what he's called? I had that on the warm-up slide. Vertex. Just going through a bunch of vocabulary words. Got X-intercepts, Y-intercepts, vertexes. All right, one thing to tell you about the vertex is depending on whether your graph is opening up or down, your vertex can be a minimum or a maximum point. So right now our parabola is opening up, so it puts that vertex kind of down in a bowl. It means the vertex can be called a minimum point. Now that would be the opposite. If it had been opening down, it would be a maximum point. And I think the only other thing I need to tell you about the parabolas is lines of symmetry. Remember symmetry from when you were a little kid? You would make butterflies, you draw a butterfly drawing like this. And you're like, here's my butterfly. And then you'd fold it in half. And the wings on either side would line up, right? Well, that's what's true about parabolas. I could take this parabola, fold it in half, right about here, and both of the sides would match up. So this guy right here is called the line of symmetry, or the axis of symmetry. And since it's always going to be a vertical line, it can always have the equation x equaling a number. This particular one looks like it's x equals 1. That line x equals 1. Right, there's a lot of information on that slide. Any questions, like, you know, trying to figure out what I've written down here? Are we good? So there's a couple of formulas you won't need to memorize, but you'll be able to use. The first one is the vertex formula. The vertex formula is x equals negative b over 2a. So that's going to give you the x part of the coordinate, and you would put that here. To get the y part of the coordinate, you would just plug the x value into the equation. That'll make more sense when we try it. The axis of symmetry would be the same exact number, x equals negative b over 2a. And the y-intercept is located at 0c. So these formulas is what we'll use over and over and over today to get all of our little features of our parabolas figured out. Okay, so on this one, the first thing I just like looking at is just the equation itself, and my eyeballs go to that -2. That -2 allows me to get a picture in my mind of what the parabola looks like. Do you guys think this parabola is opening up towards the sky or down towards the ground? Down towards the ground. Awesome, because that is a -2. Now, since it is a -2, it is going to kind of move it in a little bit skinnier than just a normal parabola would be. But let's go ahead and talk about what our A, B, and C values are. Because once we identify our A, B, and C values, we can start answering some of the questions. A is going to be the number right out front. That's that -2. That tells you the parabola opens down. B is going to be the 12. It's the number right in front of the x. It doesn't really tell you anything about the parabola, but we'll use that 12 to help us find the vertex. And then C is -7. So questions on how I identified A, B, and C. So to start yourselves off using the vertex formula, you're going to write x equals negative b over 2a. So negative b would be a -12, because I'm just plugging the 12 in for b. And 2 times a would be 2 times -2. So does that look, that setup look okay? Now, if you absolutely must type this whole entire thing into a calculator, you would want parentheses around the bottom. I'm encouraging you to do a little bit of mental math, so just calculate this out mentally. What is 2 times -2? -4 sound okay? And then we still have the -12 on the top. And then -12 divided by -4 is 3. Okay. So what we've just found is 2 things. We have found the first part of the coordinate of the vertex, the x part of the coordinate of the vertex. And we found the axis of symmetry, x equals 3, because it's just a vertical line through 3. So actually I could go to a graph and draw that in right now. The axis of symmetry. I don't really know where the vertex is quite yet, because I only know the x coordinate. Alright, to get the y coordinate of the vertex, you'll take the 3 and you'll go back to the formula. It's called plug it in, because that's an old commercial. But you plug that 3 in here, and they'll help you calculate out the vertex. So it'll be -2 times 3 squared. You can type this all in at once, plus 12 times 3 minus 7. So plugging the 3 in for x, both places. Make it 11. How's that sound? 3, 11. So now I can draw it. 3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's like right at the top of my screen. I doubt my smartboard's going to even let me right there. Right about there, okay? And you guys told me this was opening down, so that's good news because we'll open down that way. Alright, so as far as making a chart, here's what we're suggesting to you. Since the vertex is going to be smack dab in the middle of the parabola, we would put the 311 in the middle of the t-chart and maybe pick 1 or 2 values bigger, maybe like a 4 or maybe even a 5, and 1 or 2 values smaller, maybe like a 2 and a 1. That way we've got coordinates on either side of the vertex. And now it's just a bunch of plugging and chalking, a bunch of just plugging these numbers in to fill out the chart. So do you guys know the arrow up technique? If you would arrow up to the previous equation you had typed in, I click enter on my calculator, you can just change the 3's into 1's. And that's going to allow you to quickly plug a 1 into the formula. That gave me 3. If you can't figure out what I mean by arrow up, I'll show you. It doesn't know if your calculator does it. Let's see. So my calculator can arrow up. Or did you clear it?
I didn't press it.
You did put the 3 in?
Yeah.
Okay, so if I do -2 times... So we went ahead and used our calculators to fill out the rest of our values, just plugging these numbers in for x and calculating. End up graphing it, seeing that it is a parabola. You guys already told me that it opens down, so that's good. Is the vertex then going to be a maximum or minimum? Is it the top of a mountain or the bottom of a valley? Top of a mountain, so you would say that this is a maximum. And the only other question on this slide is down here below this box. It's talking domain and range. And you just ask yourself, can your parabola travel everywhere left and right? Because domain is left and right, x-axis. And parabolas always can travel everywhere they want left and right. So the domain is going to be all real numbers. Now the range is where the parabola can travel up and down on the y-axis. It only can go below 11. So the best way to answer that is that the y values must be smaller than 11. Y is less than or equal to 11. 11 was the maximum point. So on your homework tonight, they're mainly going to ask these types of questions. They also throw on their y-intercepts and x-intercepts. Y-intercepts are easy to come by because they're located at 0c. So you just grab that c value. In this case, it would be at 0, -7. We don't actually have that coordinate on our table, so we didn't find it. But as far as x-intercepts, I would just estimate. You know, this one looks like it's maybe at 1/2 and maybe up at, I don't know, 1, 2, 3, 4, 5, 6, maybe up at 6. You can just estimate those x-intercepts. All right, we'll try one more. These take so long, so we're not going to do a ton more. Just one more, okay? Just to practice using the formula one more time. Okay, so go ahead and jot it down, and then we'll identify our A, B, and C value. And we'll even do some parabola arms. Okay. All right, real quick, parabola arms. Do you think this would open up to the sky or down towards the ground? Definitely up towards the sky. It's that +3 out front. It's that positive A value. So let's identify A, B, and C. I just told you that A is 3. What's B? -6. And C? Good. get to use our vertex formula. X equals negative b over 2a. Now negative b might be a little bit of a challenge because it's the negative sign is part of the formula, and then b is negative as well. So we have two negatives in a row. What happens? Yeah, so that's going to be a positive 6 on the top. So let's erase it and made it turn into a 6. So positive 6 on the top, and 2 times 3 in the bottom. And 2 times 3 is 6, and so it looks like I'm just going to get a 1. So what we have just found is our first half of our vertex and our axis of symmetry. Because this number here and this number here must match. That's because the axis of symmetry goes through the vertex. All right, do you remember how to get the other half of the vertex? Yeah. Yep, plug it in, plug it in. Take this 1 back to the original problem and put it in for x. So 3 times 1 squared minus 6 times 1 plus 2. And I would type it. 3 times 1 squared minus 6 times 1 plus 2. I got negative 1, but definitely check my calculations for me. So as far as my table, that vertex of 1, negative 1, I definitely would have be smack dab in the middle of my table. Maybe pick 1 or 2 values bigger. Let's just pick 1 value, just save some time, and pick 1 or 2 values smaller. I'll just do 1. Alright, so I can arrow up, and this time plug a 0 in everywhere I see an x. When you guys plugged a 0 in, did you get 2? Awesome. And then down here, if you do it correctly, because of symmetry, the answer should also be 2. But verify it by plugging it in and making sure. And I'll work on graphing then. 0, 2, that's definitely a y-intercept. That's where touching the y-axis. 1, negative 1 is here. 2, 2 is back here. So it's opening up, just like you guys told me. My axis of symmetry would be running right down through the vertex, right there at x equals 1. It opens up. That's what you had told me. Would that vertex be a minimum or a maximum? It's down here at the bottom of a valley. It's called a minimum. And the only other question to answer is domain and range. So on the x-axis, this parabola can go anywhere. So it's all real numbers. But its range, the y values are always going to be bigger than the minimum value. The minimum value is negative 1. So the range is y is greater than or equal to negative 1. Recording. Alright, so that's about it today. Sorry my little boxes are covering some of this stuff. I'm going to try to get the homework on Polaris for those of you who are absent and watching this video at home, but hopefully if you missed school today, you did watch this video and you can get caught up to where we're going to be at tomorrow. Thanks for watching.